Okay, so now we're going to have Gail, and she has traveled 5 meters already. And her brother standing right here. They're pretty much at the same point, so I'm just going to have him right there. He's going to hop. He's going to hop on the slide. So let's call that B for brother. And it's going to be the mass of, just call the system now, I guess. So we have yet another inelastic collision. Same principle holds. I'm sorry if that pops up like the whole time. Perfectly inelastic, we're gonna have the same velocity, so we can take that to the bottom. It's pretty much the same problem. We know that the velocity of Gil's brother is 0 again, so, well, it's 0, so it's literally pretty much the same. So that's going to be V5. Sorry. It's pretty much the same problem, so that's the system. Sorry. It's going to be 55 times the velocity of the system, which is 10.55. Oh gosh, that's 55. That's 10.55 over plus Gail, who is 30 kilograms. So after the perfectly inelastic happens, we're going to have the 5 meters. And we're pretty much going to have this guy hop on there, and he's going to have a new mass. And we're solving for the final velocity right now, so 85. So the velocity when Gail's brother gets on the sled, 6.3 meters, 6.383 meters. Let's go ahead and get the problem one more time to finish it up. And we're gonna go ahead and hit the mechanical energy again, the conservation of mechanical energy, since they're gonna be traveling again. But this time, she has already traveled 5 and totals 15, so 15 meters minus 5 meters. 10 meters is the remainder that she needs to travel. So EI equals EF, same principle holds. KEI plus UI equals KEF plus UF. We're gonna go ahead 1/2 MV 5 MGH, sorry. 6, we're finding the 6th velocity now. So let's draw the diagram to better understand the problem. So the mass of the system, nobody's going to get on anymore, so let's just call it the mass of the system again, is right here at the top, and it's got a velocity of, what did I say, 6.83 meters per second. Right, and it's traveling down the sled, down the hill. And we have 10 meters left, so we're trying to find the velocity which they will hit right here. And we have the same principle again, so we can multiply by 2 and get rid of the masses. Mass doesn't change in this problem. to GHF. And we can set our variables to whatever we want. So let's just call the bottom 0 and the top 10. Get rid of this term again. And we have pretty much the same problem that we solved before. So B6. Now we can start plugging in variables. Our V5 is 6.83. Gravity does not change. Yeah, 10 meters right there. We can go ahead and get the square root of the whole thing. And voila, we're going to get an answer of 15.6 meters per second at the bottom of the hill. Let's just make sure that I finish the problem. I think I'm fine. Thanks for listening, Mr. Brooks.